Welcome to a new test and teardown video. This is a BBC Goerz Metrawatt Unigor A40. I actually also got a 41, and that will be the last two of this series. Oh my god, I got a lot of them. So there are quite a lot of differences, and if you look at the meter or the settings here, they're different. We got a lot more on the 41, and we got a lot less on the 40. Also, the way that ohm settings actually work is very different between the two. So be sure you look at the right video for the instrument you got, otherwise you're gonna get confused. So I'm going to skip very fast through this video on all stuff that is exactly the same. So in all those things you'll just have to see, I think you're gonna see this one, right? So all the mechanicals and the mechanical layout, everything else is very different on this on the A40 and the A41 models. Let's see the backside again. Very different. Here is one screw to access the battery, and the battery is inside the 41 model. And here it says about the adjustments for ohm is reversed. Somebody was real smart to write a little note. Battery was taken out. But see, another very important difference, and this is what I really like about the 40 model. You can see via this transparent lid the battery, and this one is using a normal AA cell. Isn't that just brilliant? Of course, 2 extra fuses, and you can see the fuse. Just too bad they're using those super slow blow with all the sand and stuff, so you can't really visually see it's broken, but you can see it's there and it's easy to access. You don't need to open the instrument, and we got 4 sealed screws to open the instrument. So let's play a little bit with the A40. Or maybe we should just go and find a battery first, right? So now we got a battery in, and this is the 40, and look at the ohms. All we got 2 ranges, times 1 and times 10. So that means we're reading the values directly or multiply by 10. So the trick is, with this one, all you have to do is short circuit, and then you adjust on this knob for 0 ohms, and then you put on your resistor and measure the value. This is the most simple way to operate an ohm meter, and I think this is like 99% of all of them in the whole world works exactly like that. Simple and super easy. Let's go and find a resistor and see if it works. This is times 1. I believe this is 100 ohms. So this will be the top scale, and this is about 100 ohms as far as I can see. Let's try something else. This is 1 kilo. Yeah, and it reads 1 kilo. Okay, and obviously when you're very close to this area, it is a very good idea to change to the other range. So this is 1 times 10. So this should be 100 times 10. And now it should be easier to tell the value. So let's play a little bit with the voltage range And again, this meter haven't really got all the features populated. You can see up here 3 things that we don't have, 2 things we don't have. Actually, we also kind of waste a setting for the 30 and 6 amp. We also need to change between that instead of just changing the input here. That is also a little bit odd for this model. And then 2 more here we just skipped. Why aren't they populated? Why couldn't this be times 100 and times, I don't know, more? We want more, right? We're skipping this one as well. And if we compare with the 41 model, see, everything is populated. We got much more ranges of everything. And also the 6 amp and 30 amp, then you just swap the input, but use the same position here on the dial. So that will give you an easier selection of everything. Okay, so the finest voltage range here is 30 millivolts. And yeah, okay, I believe this is correct, just on these 2. And that is, okay, so what is 30 millivolts? This is 1, because I'm down here. So that is 1 volt, 100, 10. Click, that is 10 millivolts. And so 30 for full range is, where are we? Here we are. So that is 10. Super duper nice. So how about that? 20. Ooh, a little bit low. 30 is also a little bit. This lamp is driving me nuts. So that was 30 again. Okay, let's hit the next. So that's the 60. So how is the 6? Oh, that's funny. So in the 60 range, now 30 is accurate. Okay, so let's go to 40. Okay, that is nice. And 50 is a little bit low. And then 60 is a little bit low. Aha, so this is, I see a pattern. Let's see if this continues. So now we are in the 300. So where are we? Okay, this is 300. Oh, we got 60. So this is a little bit confusing. Okay. 0. Okay, so here we go. That is 100. What was it? 300. Okay, 300 is here. So this is 100. Ah, that's actually quite all right. 200. Spot on. And 300. Oh, spot on. Fantastic. So let's just skip a few ranges. Otherwise, this is going to be a boring video. So that was 3. Okay, so let's go back to 0 here. And then 1. Where are we? 3 over. Okay, so that is a little bit too high. That is 2, a little bit too high. 3, spot on. Let's just crank it up a lot more. Let's go to 30. Click, and then I go like this, right? So this would be 10. Okay, a little bit over. 20 is also a little bit over. And 30 is a tiny bit over. So that was 30. Let's go to 100. So now we are in the 120 range, and the first dial here is 100. Okay, that is also quite good. So let's do the 300 range. And that is the 300. Okay, we're looking here, okay? So the 300 and where are we? So this is 100, 200 and 300 is okay. Now let's go all the way to the highest baby here. So that will be 200, 400, and 1,000. I I think that's all right. So it's not too bad or anything. Also, I want to try the milliamps. Hang on a second. I'm trying to use my Fluke as a monitor of the current. Most people don't know this, but some of these Flukes don't really have super high resolution in the milliamps or in the amp meter, and especially not the 115 as I got here. See, this meter only got 1 milliamp as the last digit. So that means I can say if it's 3, yeah. Is it 3 or is it 2 or is it 4? Come on. So I can't really use this method. This is just funny, right? So if I go to 12 and then I maybe got 3 plus minus 1, and if I crank it up to 12, okay, I got 12. But this is what, 10% resolution on this meter compared to this one, and I am all the way up here. So this is clearly not the meter to be trying to reveal the accuracy of this one, right? Absolutely not the right equipment. Okay, let's go back to the 12. We got other methods of playing with the milliamps here. So this is 12. Let me see if I can dial this as accurate as I can on this meter. Wouldn't you say this is 12 milliamps? Yep. Oy, oy, oy. So this is very accurate, and now we should be able to go down to the smallest 0.3 milliamps. Let's try and dial in something. Ooh, now my current source is funny here. I was trying to hit 2. So that should be 0.2 milliamps, give or take. Whatever you like. Yeah, I think so it is. I mean, this is some good stuff, isn't it? Obviously, it's gotta be super accurate in all the other ranges, and this is where you really see something. Let's open this thing and see what's inside. Now we're inside, and the PCB here looks a lot more modern. But there's definitely some funny kind of... Look at that. That can't be good. And look, it actually goes... What is that stuff? I don't know. And that will be all the AC currents, I guess. There's a lot of manual work with all the wiring. And inside, they made a shield that's taped and all. That one is a little bit funny. So this goes over the current overload, and this is done just like all the other versions we have seen. Oh, it's, here we go. Boing. So they got all the current here and stuff. Oi, 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 we got a lot of decks here on both sides of both PCBs. Or what is that? That is very complicated. I'm happy I'm not going to service something in there. Oh, yo, we need to bugger around with everything here. Got some trimmers for calibrations down there. Let's have a look. Okay. That will be the different switches. They are really nice. Nice to operate. Oh, we got some... What? That can't be good. Was that supposed to be like that? How can it work? There was a contact. Or maybe it was because when I... it is supposed to be all that. It is supposed to be there because this one clicks in there. So they're just very, very long. That is funny. So they're supposed to be... Really? They're supposed to be out there where they almost fall out. That is how it is supposed to be. That can't be really, really smart design. That will cause all sorts of problems. But they can't get any further out because of this holder and stuff. But really, I would have soldered these all the way up if I have seen this in the production. Of course, they don't want them to be closer to that switch. Why do I always find some production kind of problems and all that kind of stuff in almost all products I open? It's just a thing that haunts everybody. How to manufacture stuff reliable, how to do this right, and maybe they had all the good intentions and then production guys somehow screws it up. Well, there's one thing that I'm absolutely in love with when it comes to this particular model, the A40, and that is the battery behind the transparent lid. That is just absolutely brilliant idea compared to all the other versions they ever made. And I think I've seen all of them now. And yeah, that battery thing is just the best by far. Got all the different current sense resistors and we got some more trimmers. Okay, that is that one. So it's not even a pot meter, it's just a trimmer. Okay. Got pretty good resistors all over the place. Yeah, this is definitely a much more modern design. The PCBs are much newer. So at least this is what we can find out from all this. So this is the ventler. This is of course a transformator. Isn't that just fantastic? So what does this say? Aha! Maybe this is the H89. I don't know. Blah 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 37. Why can't they just reveal the H? Is that really something super secret? How about we leave this open and then we go and play with the other one so we can compare them in the other video. I think that will be what we do. So if you want to see this one compared to the 41, open and all that, yep. And then you need to open the other video. Oh yeah, one more thing I forgot to show you. I think it's good if we have the technical sheet with all the details here in the video. I'm sorry if I'm shaking the hand and whatnot. You can always pause the video, take some screenshots, do your thing. So this is the Tastenschalter, that means the push buttons. So this shows where you push and what is going on. And see, the ohms times 1, it says you adjust with your test shorted, and then you adjust for 0 ohms. They really made it so you don't even have to read anything. Just look at the